Welcome to the Podkey summary of bringing Cyberpunk 2077 to Mac from WWDC 2026. Today's catch-up is all about how Cyberpunk 2077 made its way onto the Mac. And the interesting part is that a lot of the story is less about flashy marketing and more about careful engineering choices. The team used Apple's tools to figure out where the game would struggle, then leaned into Mac-specific features like MetalFX, Game Mode, HDR, spatial audio, and smart default settings, so the final result feels native instead of merely translated. It's a good example of porting done with a little humility first. Test what breaks, learn where the machine is actually hurting, then build around that. Before they wrote native Mac code, the team ran the Windows version through Apple's game porting toolkit. That gave them an early read on whether the game was even practical on Mac OS, and more importantly, where the pain points would be. They could see hotspots, tell when they were CPU bound versus GPU bound, spot the wobble from live shader translation, and measure load from the audio middleware. That's useful because it turns porting from a vague hope into a triage list. You stop guessing and start prioritizing. One of the clearest findings showed up in the busiest parts of Night City, especially dense traffic and crowd-heavy scenes. On higher-spec Macs, the GPU actually stayed in pretty decent shape, but CPU usage spiked hard when scene complexity went up. So when frame times got ugly, it usually wasn't because the graphics chip had run out of breath. It was the CPU doing too much work at once. That matters because it changes the whole optimization strategy. If you assume the GPU is the problem, you spend time in the wrong room. From there, a big piece of the solution was MetalFX upscaling, combined with dynamic resolution scaling. MetalFX lets the game render at a lower internal resolution and rebuild a higher resolution image on screen, which opens up useful performance headroom without making everything look uniformly worse. Then, dynamic resolution scaling keeps adjusting within set bounds, so the game can hold to a 30 or 60 FPS target, depending on the device. That's especially handy in the moments where Cyberpunk gets loud visually, with heavy effects, lots of lighting, and the general chaos Night City seems contractually obligated to provide. They also added a preset called for this Mac, which is exactly the kind of plain, helpful naming I appreciate. At launch, it detects the specific Mac model and applies a curated setup for that hardware, instead of dumping players into a settings menu and wishing them luck. That includes things like target frame rate, HDR, VSync, and resolution limits, all tuned per device. So the first run experience is meant to feel sensible right away, which is a bigger quality of life win than it sounds like on paper. A lot of polish came from hooking into macOS notifications directly through NS Window and NS Application. The game listens for things like occlusion state and screen changes, so it can pause rendering when it's backgrounded and adapt its window sizing if you move it between displays. It also switches cursor behavior based on whether the game window is active, using the standard resign key and become key notifications to swap between the custom in-game cursor and the regular system cursor during overlays. None of that is glamorous, but it's the difference between software that technically runs and software that behaves the way Mac users expect. On top of that, Cyberpunk 2077 automatically benefits from Apple's Game Mode. That boosts CPU and GPU priority for the game, tones down background tasks, and doubles Bluetooth sampling rates, which helps reduce latency for wireless controllers and even AirPods. The nice part is there's nothing to configure. It just turns on automatically. That same low-friction approach shows up in HDR too. Using Apple's extended dynamic range pipeline, the game checks the display's maximum extended dynamic range color component value in real time and feeds that into its tone mapper. If the display's potential EDR clears a threshold, like 2.0, HDR gets enabled automatically. So on XDR and other capable screens, players get the right result without a calibration ritual. Audio got the same native treatment. The game's spatial audio middleware ties into Apple's AV audio engine. And with listener head tracking enabled, AirPods users get head track spatial audio by default. So as you move your head, the 3D sound field responds, which is one of those features that sounds gimmicky until you try it and go, okay, that's actually pretty neat. There's also cross-device save support through iCloud Drive, tied into the studio's cross-progression system. That means a save can move between Macs, iPhones, and consoles, so a playthrough isn't trapped on one machine. One more important piece of the port was the shader workflow. The team integrated Apple's Metal Shader converter into the build pipeline, so metal shaders were generated alongside the game's existing shaders on every build. Then they kept testing those converted shaders against lighting, materials, and post-process benchmarks to catch edge cases and keep the visuals in line with the Windows version. That kind of pipeline work is what makes rapid iteration possible. You can keep checking quality without turning every visual fix into a long detour. Taken together, this sounds like a port built by people who paid attention to the unglamorous details and the hardware realities first, then layered in the nice stuff. And honestly, that's usually how you get something that feels smooth, modern, and native, instead of like it arrived by accident. Night City on a Mac still sounds a little surreal, but here we are. This episode was generated by Podkey. Create your own at podkey.fm.